Have you ever wondered what the secret is behind some of the best foods and drinks in the world? You know, that perfectly crusty loaf of bread, a really sharp cheese, or a fantastic bubbly beer? Well, it all comes down to a kind of ancient, almost magical process. We're talking about fermentation. And today, we're going to break down its secret recipe, step by step.
So, what is fermentation really? At its heart, it's a pretty amazing transformation. You've got these tiny little living things, microorganisms, right? And they basically eat sugars. In return, they create something totally new, like alcohol or different kinds of acids. This is the powerhouse process behind not just our favorite foods, but also things like biofuels. It's like nature's own little factory.
But here's the thing, getting it right isn't always easy. It's this super delicate balance of biology and chemistry. So what is the secret formula? What are the key things you absolutely have to control to get that perfect loaf of sourdough instead of, a sour mess? Well, that's exactly what we're about to uncover.
All right, so every great recipe starts with the right ingredients. It's no different for fermentation. There are two things that are completely non-negotiable. You need something to transform, and you need something to do the transforming. Let's think of them as the fuel and the worker. This slide just breaks it down perfectly. So on one side, you have the substrate. That's our fuel. This is usually some kind of sugar that the microbes are going to eat. You can think of it as the what of the whole process. And on the other side, you've got the microorganism. That's our worker. This is the little living engine, the yeast or the bacteria that does all the heavy lifting. That's the who. You absolutely need both for any of the magic to happen.
And here are some real-world examples to make it super clear. For the fuel, or the substrates, you've got things like glucose and fructose. Those are the sugars in grapes that yeast just loves to turn into wine. Or a lactose, which is the sugar in milk that bacteria convert into that tangy lactic acid that makes yogurt so good. And for our workers, the real stars of the show are yeast, bacteria, and even some types of fungi. Each one has its own little specialty.
Okay, so we've got our ingredients, but, just like baking a cake, you can't just toss them in a bowl and hope for the best, right? You have to create the perfect environment, the right kitchen conditions for your little workers to do their best work.
First up, let's talk temperature. Think of this as your oven dial. There's a total sweet spot where these microbes are at their peak performance. If it's too cold, they get all sluggish and slow down. But if it's too hot, you can actually damage their cells or create some really weird off flavors. This is literally the difference between a cold-fermented, super crisp lager and a warmer-fermented, much fruitier ale. Both are beer, but temperature completely changes the final result.
Next up is pH, which is really just a measure of acidity. And just like with temperature, there's an optimal range here too. Usually somewhere between pH 4 and 5 for yeast that's making alcohol. If you stray too far from that, you can stop the enzymes the yeast needs from working properly, or worse, you might create a perfect home for other microbes that produce stuff you don't want, like acetic acid. And trust me, nobody wants their beer to taste like vinegar. This is why controlling pH is so important. You're literally controlling the final flavor.
Now let's talk about oxygen, because its presence, or its total absence, is a complete game changer. So for making the ethanol in beer or wine, you need an environment with zero oxygen, what we call anaerobic. If you let too much oxygen in, you trigger something called the Pasteur effect, which is basically where the yeast stops making alcohol and switches gears. And that is how your precious wine can turn into vinegar. But on the flip side, what's called the Pasteur effect here shows how a complete lack of oxygen can sometimes prevent the microbes from growing in the first place. It's an incredibly delicate balance.
Okay, we've got our ingredients and our environment is all set. Now we get to the final part of our recipe, the technique. This is all about how you actually manage the process from beginning to end to make sure you get a perfect result.
So let's run through these steps real quick. First, you need a really strong kickoff with a healthy starter culture, or inoculum. Then, you need just the right amount of agitation, stirring, enough to mix everything up, but not so much that you stress out your microbes. And finally, timing is everything. You have to know exactly when to stop the whole thing to get the flavor you're after and avoid spoilage.
This quote from the source material really hits the nail on the head. Excessive agitation can cause sheer stress, damaging microbial cells. It's just a fantastic reminder that we're working with living things here. They're delicate, and our physical technique has to be gentle and super precise.
And here are two final kind of expert-level controls to think about. First, you have got to keep things clean. A sterile environment is what stops any rogue microbes from crashing the party and ruining your batch. And second, in some big industrial systems, they'll actually remove the product, like the ethanol, as it's being made. Why? Because too much of the final product can actually poison the very microbes that are creating it. Pretty wild, right? So, we've covered the ingredients, the environment, and the technique. For thousands of years, this was really an art passed down from one generation to the next. But today, our understanding of it is evolving so fast, and that line between art and science is getting blurrier and blurrier.
And this is where we get to the really cutting-edge stuff. Scientists are now designing genetically modified microorganisms. These are microbes that are literally engineered to be more efficient, more productive, and way more resilient to stresses like high heat or acidity. It's like we're building these microbial superworkers, specifically designed to perfect this ancient process.
Which, of course, leaves us with a really big question to chew on. As we engineer these microbes and control every single variable down to the decimal point, is fermentation becoming purely a science, or will there always be a little bit of room for that old-school art and intuition? It's definitely something to think about the next time you enjoy a great piece of sourdough or a glass of wine. Thanks for tuning in.